Hey guys, let's start talking about differentiation rules. So differentiation is just another word for finding the derivative or the gradient of the tangent line of a function. So the thing about calculus is there's a lot of different words that all mean the same thing. So differentiation, find the derivative. Sometimes they'll ask you to obtain f prime of x. That's said f prime of x. That's the derivative of f of x. dy dx is when we have y equals a function, and we'll differentiate with respect to x. When you get into Calc 3, more advanced calc, things like that, you could have equations of different variables and differentiate on which specific variable would help in the moment. So, okay. So here are some of the basic rules. So first of all, if your function is a constant, so let's say y equals 3, that's a horizontal line at 3, right? The derivative is going to be 0, and here's why. Horizontal line at 3, what's the slope? 0. Makes sense, right? Then if we have a constant multiplied by some function, we just take the derivative of that function and multiply the constant by that. A lot of times, we're going to have little things that are all added together, and we just find the derivative of each of them and keep them added together, or the next one, subtracted. That should be a minus sign right there. My mistake. Now, this is the big one for today. This is called the power rule. We're going to bring the power down. Oopsies. Let's go over here. We're going to bring that power down and multiply, and then subtract 1 from the power. Bring the power down and multiply, subtract 1 from the power. So let's look at this first one. We want to find dy dx, so the derivative of y with respect to x, dy dx equals, we're going to bring the power down and multiply, and then subtract 1 from the power. We have a minus sign in the middle. Remember, that's x to the first. I'm going to bring my power down and multiply, and subtract 1 from the power. So, 3 times 2 is 6. 2 minus 1 is 1, so just 6x. Then we had a minus in the middle. 4 times 1 is 4. 1 minus 1 is 0. X to the 0 power is just 1, so it's not there. So dy dx is equal to 6x minus 4. So interpret its meaning. This is the gradient of the tangent line. Of y equals 3x squared minus 4x. And then remember, we could plug in a value to figure out what the gradient of that tangent line is at a specific point. Okay. This next one, we want to find f prime of x. So f prime of x equals, so we're finding the derivative. We're going to bring this number out front and multiply. 3 times 5 is 15, x. Then we'll subtract 1 from the power, so 3 minus 1 is 2. We'll bring our power down and multiply. 2 times 6 is 12, x, and then subtract 1 from the power, so we'll have x to the first, or just plain old x. Over here, we'll bring our power out front. 3 times 1 is 3, then we'll subtract 1 from the power, so 1 minus 1 is 0, 3 to the 0 power is just 1, there's nothing there. And then we're going to take the derivative of 2. Remember, the derivative of a constant is 0. So he just kind of goes away. So f prime of x is going to be 15x squared plus 12x plus 3. Okay, now we want to differentiate this next guy. That's a nice way of saying we want to find g prime of x. We want to find the derivative, find the gradient of the tangent line, things like that. So what can be helpful right here is to rewrite our powers. So remember from our exponent and exponentials unit, when we have something in the denominator, that means our power is actually negative. So I really have 4x to the negative first here for g of x. Plus, and then remember, if he's on the bottom, he's going to be moved up to the top, and he's going to have a negative exponent, x to the negative third. So we're going to keep on doing what we've done. So to find g prime of x, we're going to take our power here of 1 and multiply it. 7 times 1 is 7. Then we'll subtract 1 from the power. 1 minus 1 is 0, so x to the 0 just 1, so it's 7. Cool. Now we're going to bring it down and multiply. Negative 1 times negative 4 is positive 4, so we'll have plus 4. Then subtract 1 from the power. Negative 1 minus 1 is negative 2. For here, we'll bring our power down and multiply. 3 times negative 3 is negative 9x. Then we'll subtract 1 from the power. Negative 3 minus 1 is negative 4. So you can leave it like that, or you can always rewrite it with positive exponents. So we could also write this as 7 plus 4 over x squared minus 9 over x to the 4th. Okay. Now we want to find the slope of the tangent line at x equals 3. So what we're going to do is first we're going to find the derivative. We're going to find dy dx. Then we're going to plug in 3 for x. Okay. So I'm actually going to rewrite this first as y equals x squared minus, he's to the first, but since he's in the denominator, that means I have a negative exponent. So I have 4x to the negative first. All right. Now let's find the derivative. dy dx. We'll bring that 2 out in front. 2 times 1 is 2. X. 2 minus 1 is 1, or just plain old x. Do the same thing over here. Negative 1 times negative 4 is positive 4. Then we have x, subtract 1 from the exponent. Negative 1 minus 1 is negative 2. I think it's easier to just plug in things if we have them written as fractions. So this is the same thing as 2x plus 4 over x squared. Cool. So we found dy dx. Now to find the slope of the tangent line at x equals 3, we're going to go ahead and plug in 3 into this equation. So we're going to have 2 times 3 plus 4 over 3 squared. So 2 times 3 is 6 plus 4 over 3 squared is 9. All right, so we would get 6 and 4/9, or let's see, that would be 54 and 4, I'm sorry, 54 and 4 gives me 58/9 for the slope of the tangent line. Either one of those answers. Okay, now we just want to go ahead and find the derivative. So What can be helpful with radical ones like this are to go ahead and turn that radical into an exponent. The big thing when you're dealing with differentiation and later integrals is that if you see a fraction with a power in the denominator, or a variable with a power in the denominator, or you have a radical, please put that as an exponent. It'll make your life a whole lot easier. So we know the square root, that technically has a little 2 right there, and we know x is to the first power. So one way that we could rewrite this is x to the 1/2. Remember, the exponent goes on top, and whatever root you have goes on the bottom. All right. So the same rules apply. If we want to find the derivative, or dy dx, I'm going to bring down and multiply by my exponent. 6 times 1/2 is 3x. Then I need to subtract 1. So I'm going to have 1/2 minus 1, or 2 over 2. That's easier to think about it that way. We're going to end up with x to the negative 1/2 there. 3x to the negative 1/2. So you can leave it like that if you'd like. You can also leave it as 3 over x to the 1/2. That's also the same thing as 3 over the square root of x. Any of those would be fine. Those are all the same thing. All right, let's look at the next one. So we're going to rewrite that 4th root of x. Remember, he's to the first power. So to rewrite this, we've got f of x equals 3 x to the 1/4. So remember, that root goes in the denominator of my power. So I'll bring this to find f prime of x, to find the derivative. 3 times 1/4 is 3/4 x. And then I need to subtract 1, so that's the same thing as subtracting 4 over 4. So we've got 3/4 x to the negative 3/4 for f prime of x. I'd be happy with this answer. Or if you wanted to have positive exponents, you could put that x to the 3/4 in the denominator. Or if you wanted to turn that back into radicals, you'd have 3 over 4 times the 4th root of x cubed. So lots of different ways to write that answer. Okay, on this one, you might be like, we don't know how to do that problem, Mrs. Davis. All you told us how to do was how to mess with powers. Yeah, I know, so think outside the box. So, we're taking 3x minus 6 and dividing by x, right? So, let's take 3x and divide by x. And let's take 6 and divide by x. Well, now 3x divided by x is just 3. And I still have 6 over x. So that's the same thing as 6x to the negative first. And now that we've written him like that, he's easy peasy lemon squeezy. So let's take the derivative of y. So dy with respect to x dx. The derivative of a constant is just 0, so that goes away. Then we'll multiply, bring down that power. Negative 1 times negative 6 is positive 6x. And then we'll subtract 1 from the power. Negative 1 minus 1 is negative 2. And you could leave it like that, or you could rewrite it with with a positive exponent in the denominator. 6 over x squared. Over on D, there is a product rule and things like that, but we can also do is rewrite it by multiplying it out. X times x is x squared, so on and so forth. We'll end up with x squared minus x minus 2 when we multiply that all out. And then he's easy to find the derivative of. Multiply 1 times 2 is 2x. Subtract 1 from the power, 2 minus 1 is 1, or just plain old x. My exponent here is 1, bring them on down. Negative 1 times 1 is negative 1. X to the 1 minus 1 is 0, so that means I don't have an x there. Then the derivative of a constant is nothing, so that goes away. So my derivative is 2x minus 1. All right, go ahead and look at that practice. See you guys later.